Okay, we're in the home stretch now. We're going to take all the measurements that we took off the car while we were building it and create a model in RC Crew Chief. So first thing is open up the chassis manager. And what we're going to do is we're going to add a new chassis. So click that button and then we can select one from the list here. What you want to do is select one that's as close as possible to what you're trying to create. In my case, I already have a TC7 TC7 model, so I'm going to select that. You're presented with options here that you can copy all this information from this model into the new model, which is what I would normally do because the TC7 is very close to the 7.1. But that wouldn't teach you anything because there's some things within the hinge pin and camber link positions that I really need to show you and you need to understand. So we're not going to copy those in. We're going to enter them as we go along. So TC7.1. So I'll just click Add Chassis Model. There we go. It's copied everything over. You can go through and change all these values to what you actually measured. I'm going to change a couple things here. I'm just going to change the front track to 186 and the rear track to 182, and the rest of it's fine as it is. So I'm just going to save that. So now we're going to go into the front suspension and enter all the values that we measured off the car. So the camber was minus 1.5. The X1 dimension is the same. The Y1 is the same. The arm length is the same as the TC7. So you can see a lot of these things are relatively easy to deal with. The X2 dimension is the same. The Y2 is the same. The camber link, I got a little different measurement. I got 46.53. Kingpin length, which was taken with a 1mm shim underneath it. So what I've got is 35.62, and the axle height is the same. So that's all great. So now what we're going to do, you can see here we've got our graphic that shows our suspension with all the reference points that we just entered here. These points are used as references for our alternate positions that we can enter here. So first off, I'm going to go to the inner camber link. So what you want to do is identify what the their reference position is. So in this case, this is plus 1 millimeter, and that is our reference point. So our offsets are 0. So if we want to do a no shim case, so 0 millimeters, that would have a vertical offset of minus 1. Then if we want to do a plus 2, that would be 1 millimeter up. So now you can see there's our reference point. There's our plus 2, which is 1 millimeter above our reference, and there is our 0, which is 1 millimeter below our reference. Now for our other positions as we move inward, because this link was mounted in the outermost position, we can move to different locations by changing our horizontal offset. So our 0 for our horizontal would be minus 2, and the vertical would be 0, or sorry, minus 1 for the 0 millimeter shim. Make that 0 millimeters. And similarly, we could do the plus 1 and plus 2 and the other positions, but I'm not going to bore you going through all that. But you can see how important this reference point is. You need to make sure that you note that when you're measuring up the car. It's either that or you take all your shims out and you do it with 0 shims, but then you're going to have to go back in and add all those things back in as you build the car. So similarly, the outer camber link, same thing. The outer camber link had a 1 millimeter shim under it, so it's plus 1 millimeter, horizontal offset 0, vertical 0. So if we wanted 0 millimeters, we would do horizontal offset 0, and we would do -1, and then we can build a whole grid there. We can go with whatever resolution you want. If you want to go a 1/4 millimeter, 1/2 millimeter, whatever. Okay, now let's look at the inner arm positions. This is where things can get a little bit tricky. I'm going to close this out first. Because we have different block inserts that we can use, there's a number of different positions and combinations of positions that we can come up with for the lower hinge pin, depending on which block inserts we're using. So what I've got here is just a little CAD layout that shows the different positions. So we've got -3 dots, -2 dots, 1 dot, +2 dots, +3 dots. So basically there's 3 different block inserts for the TC 7.1 and you can flip them the other way around to get the negative. So the negative means that it's pointing to the inside. The positive means it's pointing to the outside when you put the block insert in. So we've got the forward one and the rearward one, and we can come up with a bunch of different combinations of those. So what we want is we want the distance to the midpoint of the hinge pin. So you can see here I've got a 1 dot, which is my reference point, and I've got +2 and +3. So I just drew a line connecting them, which would represent your hinge pin. So we could have a 2 dot, 2 dot, and we could have a 1 dot, 3 dot, both giving the same intersect point. So what I use is a little short form that I came up with to tell you which combinations will give you that hinge pin location. So we could have a +2 dot, +2 dot, or a 1 dot, +3 dot to give you the same location with a 0.5 millimeter offset from our reference point. So let's go ahead and enter in some values here. So the reference point is a +1 dot, +1 dot, and the horizontal offset 0, the vertical offset is 0. Now this one was measured with a 0.5 millimeter shim underneath it, so I need to add 0.5 millimeters to that. Oops. So we know that that's our reference point is 1 dot 1 dot with a 0.5 millimeter shim. So we could do a 0.1 dot. Dot with 0 millimeters would be -0.5. So there you can see now our reference point, and we have our 0 point as well. So the other condition that we had there was we had a +2 dot, +2 dot, /1 dot, +3 dot. And again, I should put in here. So if we wanted to do that with the 0.5 millimeter shim under it, so our horizontal offset would be 0.5 and our vertical would be 0. So there we've just added that point. And so you can go ahead and you can build the whole grid. I'll show you the grid when I get it all done, but I'm not going to do that in front of you because you'll all fall asleep. So let's just save and exit that. So you just go through and you change that. You can also add different hub positions for the outer hub connection. These are only in the vertical direction. Normally you don't have cars with that, but that is starting to become something or somewhat of an adjustment that you can make on your cars, because it does have a dramatic effect on your roll center positions. Okay, rear suspension. I'm not even going to go through that. It's going to be exactly the same. I'll just click save there so that it shows the graphic. You would do exactly the same thing here as you did with the front. The steering types. So make sure you select the steering type first. We can just enter our numbers here. Caster is 4 degrees. Our toe angle is -0.5. XSA 6.35. YSA is 29.15. So these are the points of the relative location of the hub steering connection to the tie rod. LCC 56. XBS is 8.919. T 56.28. SB 26. Rack is 26. And RB is 18. So we save that. And then we can look at our model, and your model should look like your car. If it doesn't, then there's something wrong with your measurements or your calculations. Now we also have alternate points here that we can enter for the outer hub connections. So if we call this one, let's call it out, that's our reference point. Again, we use the reference point. Then we can do our inner one, which is going to have a horizontal offset of 2 and a vertical of 4. So there you can see we've added the alternate point. And you can do the same thing with the steering rack. Now, the reference point was measured with, again, a shim under it. So it had a 1 millimeter shim. So if we call this +1 millimeter, and then we can do a 0 millimeter, which would be -1, and +2 millimeter, which would be +1. So again, you can build this up and you can make this grid as fine as you want to, but I'm not going to go through and add a whole bunch. So there we've got our front, or our steering rack with 3 different shim points on it. Next we got our shock mount. The shock mount, very straightforward. So the number of mounting holes we've already entered all these values because they were copied over from the TC7. So the lower shock mount point is the same. The upper point is going to be different because these are the short shocks. So our X1 is 27.07. Y is 44.5. Xn is 32.67. And Yn is 48. Okay, so we've got 4 points, and if we want to look at that, click on our front shock, and again, this should be a close representation of what your car actually looks like. If it doesn't, or if it isn't, then there's something wrong with your measurements. Okay, rear, the same. I'm not going to go through that. The shock itself. So it's going to come up and say there are no shock models entered. Fastest way to do this is to just select the closest shock model to what chassis you're running. There's some generic ones here that you can use that should be pretty reasonable. And once you've got that entered, then you can adjust the values to your actual measurements. I'm not going to bother going through that. It's too boring, but one thing I do want to point out is you can add different pistons here. So if we wanted to, for example, say we wanted to use a 3 by 1.2 millimeter, so we give it a name that means something, and we put in the number of holes, 1.2, 9.9, and 1.85, because our piston diameter and our thickness of our piston is going to be the same. So let's save that. So now we've got 2 different pistons that we can choose, and we can look at the effects of changing the size of the holes. You could do different numbers of holes and so on. So we also need to look at a rear shock as well. So when you click on that, it's going to say there is no model, and you want to use the values that you currently have entered for the front. So in this case, the front and rear shocks are the same. So yeah, that sounds like that's going to save us some time. And there we go. Now we've got our rear shock, which is going to be identical to our front shock. Okay, springs. One thing I said I was going to do is show you how the spring rate calculator works. So we'll do a quick comparison here between the blue shock. So we're going to just enter in here the blue shock, and you'll see here the the spring rate in metric units is in newtons per millimeter. Well, Associated provides their spring rates in pounds per inch. So what we need to do here is just change over to imperial for a minute. And we can enter the spring rate of a blue spring, which is 15.8 pounds per inch. So let's compare that to our spring rate calculation. I'm going to save that. And I want to convert back to metric because all my measurements are in metric. So 15.8 pounds per inch is 2.77 newtons per millimeter. So let me just get my spring rate measurement out here. So the spring diameter, the wire diameter is 1.4 millimeters. The inside diameter of the spring was 14.1 millimeters, and the number of active coils was 3.5. So if we calculate that, we get 2.92. So not exactly the same. I'd be shocked if it was, but it's pretty darn close. And if you don't have anything better, use the spring rate calculator. Biggest thing is making sure you have the number of active coils correct. And I showed that in the video earlier as to how to determine the number of active coils. Okay, so you can go through and you can add in as many springs as you want here. You can add in different manufacturers. Again, I'm not going to bore you with that. Best thing though is if you have the spring rates from the manufacturer to use those numbers. If you have a spring rate tester, even better, but unfortunately most of us don't have that, and some manufacturers don't provide the spring rate, so you need to use this calculator to determine it. Okay. Anti-roll bar, very similar. The anti-roll bar, just go through one quick one here. So we'll say this is the front, and it is the 1.4 millimeter, and our D bar is 1.4. Our LARB, which is the length of, or the connection point of the anti-roll bar on the suspension arm, and we measured that as 23.08. So now we need to calculate the stiffness. So our wire diameter is 1.4. The L1 dimension is 34. The L2 dimension, which is the length of the anti-roll bar arm, is 40. And the radius, the vertical distance from the center line of the bar to the connection point of the link to the suspension arm, is 29. So we just click calculate, and there it's calculated the anti-roll bar stiffness for us. So we can just copy that directly over, and we've got it there. So once you've got the first one entered, usually it's just a matter of changing the wire diameter, calculating it. Click over here. Oops, that's the wrong way. Copy it. And we need to add a new one, so we got front 2 millimeter. And just change this to 1.2 and calculate and copy that. So you can just go through and create all the different anti-roll bars that you have for your particular chassis. There's a number of different types of anti-roll bars. This one is a blade, has a fairly thick anti-roll bar, and it would have a blade in between. There's a wire plus a bar, which was a very stiff bar with just wires coming out. This was one that Associated used back in the TC6 days, I believe. And there's also a blade type, where you just change the stiffness of the anti-roll bar by changing the angle that the blade is located at relative to horizontal. And then there's what's called a wire beam. This is used a lot in fifth scale. So it's a wire with a ball in the middle, and fairly straightforward to complete those calculations. So, okay, that's it for the chassis manager. Next, we're going to do enter the car and the mass properties. Okay, so now we're going to essentially build a car using the TC7 chassis. So we're going to open the car manager. What we're going to do is we're going to build a new car. So our new car is going to be TC 7.1. The chassis, we're going to take our TC 7.1 chassis that we just created. Motor, if you have lots of different motors entered in the program, you can pick whichever one you are currently using. So we'll select one from that list. The battery. Battery, you can create different battery models depending on what I've got here is ones that are at different state of charge. So we'll just use the default one that I've got here in the list. And you can put whatever notes. So this is just going to be standard, just all standard parts. And now what we need to do is we need to do our mass properties. So easiest way to do this is if we click the CG calculator, and we can just enter in all the values that we measured. So we had the car on the 4-wheel scales, and we measured weights on each corner. So we just enter all these values. And it will calculate all the static wheel weights. Our wheelbase was 254. Loaded tire diameter, we're using 63mm rubber tires, so what it's showing here is half of that. There will be a little bit of deflection due to the weight of the tire, so I usually use 31. The height at the rear, with my little jig, is 102 millimeters, and the total weight on the front wheels with the rear raised up. Remember, we took a bunch of different measurements here, took a total of 5 and averaged them, and that comes out to be 686 grams. And click calculate, and there's the resultant value. So now we can just copy those values to the car, close this out. The only other thing we need to do here is enter our front and rear unsprung masses, which we measured. So we had 123.4 for the front, and the rear was 110.6. So there we go. We can also add our aero constants here. There's a few different versions. What this is needed for is if you're doing any of the acceleration calculations, you need to enter these values because they are the forces that are resisting the car movement. Mechanical losses, this is how efficient your drivetrain efficiency is. You can change your efficiency to whatever value you want to use. 85% is a good starting number. You can go up from there. and the rolling resistance is resistance of the tire, the frictional resistance of the tire as it rolls along the ground. So that's it. So we got all those values entered. Click save. And that's it. We're all set to go. What I'm going to do here is okay, so now we have a car, chassis, battery, motor, and ESC assembled, and we can start playing. So if we go into setup, first time we go in that, it's going to say no setup found because we haven't entered one yet. So and what it's going to do is it's going to set everything to the default value. So first thing is to just give it a name. So we'll call it kit setup. And your suspension links should all be set to your reference values. Your springs and shocks, you need to select those. So this has a blue and a blue. The front anti-roll bar was blue and the rear anti-roll bar is white. So click save. So there you've got your essentially your reference. You've got your steering. Everything is entered in there, and then you can start playing. Okay, that's it.